This first example of doing JavaScript canvas animation is going to use separate image files. So with this, we are going to have an image for the sky, the unicorn, the cloud, and then we're also going to need an array to hold the image files for an animated object. Because if we're putting the sky on screen, we create the sky image, then we set the source for it, and that'll be sky.png, and it is here. There's our sky. It's both the day and night sky combined into one. But when doing the unicorn is going to need to store multiple files. So all of these images for it come out of the UW folder, which is the unicorn walk folder. We see that they're numbered 1 through 12. Now, to store those into the uni-image files array, what we have to do is figure out that source the same way that we said sky PNG, cloud N, PNG. The N one is the night one or the darker cloud. Here I need to grab out of the UW folder the unicorn walk, and I'm trying to figure out how to get 4 numbers, because I can't just use I, because I starts out at 0, but this one starts out at 1. But also it's 0, 0, 0, 1, but by the time I get to 12, it's 0, 0, 1, 2. So if I keeps going up, and if I just put 3 zeros in there and then I, that wouldn't work, because I need to format that number to be 4 characters long. And there's a method built into JavaScript called pad start. And this is what we can use to format that. So I say I want 4 characters. So I want this string of numbers here, which starts out at the number 1. I want it to be 4 numbers long. And if there's a missing number, then I fill it in with zeros. So that will give me 0, 0, 0, 1, but also then 0, 0, 1, 2. So it won't add 4 zeros to 12. It will make the total length of that 4 numbers long. So with pad start, it makes it 4 numbers long, which matches the 4 numbers in the file names. And then we tell each image to add event listener load, and then it will call the image handler. When it does that, then that allows us to wait till all the images are loaded before we start animating. Now, the image load handler, we're going to have a variable that we use, which is images loaded. And then if images loaded is equal to our image asset count, then we call the next function, which is start animating. Now that image asset count, I put in 2 plus 12. So 2 are the first 2 files I loaded, sky and cloud. Then the 12 is the 12 frames that make up my unicorn animation. So with that, I have 12 frames representing my unicorn animation, 2 frames my static artwork. That gives me a grand total of 14 items that are going to be trying to be loaded. When we begin, images loaded will be 0. After each image calls image load handler, because it's completed loading, images loaded increases by 1. Once images loaded is maxed out and equal to our image asset count, then we get to call start animating. We'll talk about start animating shortly, but first what we will need to talk about is our sprite object that we're going to work with. The sprite is going to have a set of properties that we will use and methods that it can do. So it's going to have properties that determine qualities of the artwork, and then it's going to have an update function and a display function, and then we'll make the objects and do fun stuff with them. Looking at the sprite object. Now, one thing that's going to happen when we go from separate file animations, then we work into sprite sheets, then we work into texture atlases. The sprite object itself is going to be very similar. We will have some changing of properties, but the core essence of what it's doing is going to be the same. So the sprite is going to have source x and source y values. So these will be the starting values that we're setting with an object. We're going to have destination x and destination y values. These are going to be where we want to draw them on screen. Sprite width and sprite height, self-explanatory. Vx and Vy, that's our velocity in the x-axis, velocity on the y-axis. Current frame, we'll start that out at 0, so we always start our counting of current frame at 0. If an object is only one frame long, its current frame will always stay 0. We'll default frames to have a value of 1, default columns to have 1, and our frame images to be an array. So frame images is going to be that array. So in this case, our uni image files will be that array for the unicorn. If we have other animated sprites we're putting on screen, then we would set their frame images array equal to that value. Looking at update, update uses simple asteroids wrapping techniques, so that if an object goes off to the left, it reappears on the right. If it goes off to the right, reappears on the left, goes off top, reappears on the bottom, bottom, top. So we have simple screen wrapping asteroid style as a way just to keep our objects on screen. So if we're animating rain or snow that's falling down, it wraps vertically. If we have an object like clouds or a character animating across the screen, it animates horizontally. So it does the horizontal screen wrap versus the vertical screen wrapping. Same stuff. Pretty straightforward. Display, this is where we get to cycle through the frames. If the artwork only has one frame, this keeps running, but it doesn't do anything. If our artwork has multiple frames, so we set that when we create an instance of the object, then we're going to see this code come into play. And if you like the one-line version of doing the advancing frame, you can uncomment and use that one at the bottom if it makes you happy. I like this one better. Makes me happy to use that, but if you want, you can use this version as well. Update the current frame. Then if current frame is equal to the total number of frames, then we set current frame back to 0. So that creates the wrap, and that's what this one line of code does. So current frame goes up by 1, divided by the total number of frames. We keep the remainder. That's what the percent sign does. It's the modulus math operation. And if we do that, it creates that perpetual loop as well. In this case, it goes 0 through 11, 0 through 11, because that will be the remainder that we get to keep every time that we divide current frame plus 1 divided by our total number of frames. So this right here, this setup is our core sprite object. So we set it up with a variable. When we're creating something that's a pseudo class, now JavaScript does support classes, but we're still using the non-class syntax for it just because it fits with a lot more examples you're going to see, because classes haven't been they're not everywhere yet. So eventually you'll see more and more uses with classes, and you can study that as well. But when we designate something to be a class style object, convention is we name it with a capital letter. So that's where I have said sprite. We define the properties with key value pairs. The key value pairs are separated by commas. So comma, 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 comma. Then we have just basic values, a name, key, and then a number associated with it. And then I have methods that are also part of it. So I name the method, and then the value, so my key is update, the value is this function, which is filled with that information, or it goes all the way to here. Then do comma, and then my final one there, and then this right here, and sprite. That is our core sprite object that we're going to use on this file. Now to actually deploy it, I say let uni be equal to object.create, and then inside parentheses I specify the object that I'm basing uni on, and in this case I'm using the sprite object. I've hard-coded in the width and the height of it. Now, one thing about using separate files like this, we don't have a data file that we're loading where we can just grab the data dynamically from that. So we have to know what that value is. We can get properties on the object and go find it out that way. So if I look at the object here, I can see, well, maybe what its dimensions are, or I have to go open it up in an image editor, open it up in Bridge or something like that to get that information. So we don't have all of the data that we need unless we know that ahead of time. So I have to know what is the width, what is the height. Now, I know that the position I want to put this on screen is 200, which happens to be the height of my canvas. And then I'm going to subtract out the height of the object. That will position it so it's walking right along the bottom of the screen. That's the basic math that's happening there. The height of the canvas, which is 200, minus the height of the object. Because when we are looking at an object animating on screen, we think of it as a rectangle or a box, and we measure its location by the top left corner of that object. So that's the location that we're using to show that to us. "12 frames, I know that because I can look at my files that I have here and see there's 12 files. We don't have columns going on. Columns will be used when we have a sprite sheet. So if we look at the sprite sheet that goes with this particular item, the sprite sheet, when all the images are in one, it's 2 columns. And we'll be looking at that with sprite sheet animation next, but right now we're doing simple single files. Giving the unicorn a velocity on the x-axis of 1 to get him on screen. Now, to do my cloud objects, if I look at the unicorn object, and if I look at a cloud object, so each cloud is going to go into my array holding those clouds. And I know how big a cloud is. It's 100 by 69 pixels because that's how big it was when I made it. So that's how I know that information. And the clouds are going to be randomly put somewhere on the screen. They have a negative x velocity, so they go the opposite way that the unicorn is walking, just because, well, why not? So each cloud is there. Now I could set it up. Each cloud is a slightly different velocity if I wanted to set that up, but we'll just leave it at 1 for now. If you want a different velocity, you can always use math random and set that up. Remember, math random gives you a value between 0 and up to, but not including 1. You multiply that by the range of numbers you want to receive. That's it. It gives you what you're aiming for. So that puts all of the clouds into my clouds array. I have my unicorn, which has frames array. Now you'll notice I didn't, for the cloud, say how many frames it has. I didn't say what frame images it has because I don't have to. When we're basing an object on another kind of prototype object, that prototype object, when it has defined values, those are the defaults. And if I don't give the object a new value, it uses that default value. So I don't have to add that in each and every time. So that's a good time saver. Now that I have my objects defined, where I've defined the sky, I have defined my clouds. Now, I'm going to go grab my canvas object and you may notice that there's some weirdness going on here where we have canvas width and canvas style width set. And what is happening with this is if I use JavaScript to write text to the canvas, it often looks a little bit fuzzy. It looks blurry. It looks like it's low resolution. And what we're able to do is we can then set where we actually create everything at double size, and then we shrink it down by setting its style property. And then when we do that, we're able to give us, in essence, increased resolution on screen, so it cleans up how the text will appear. So if we're writing text to the canvas, we will see some weird things happen sometimes. Once we have the canvas object, and we always need to remember to grab the context, because all the commands to draw to the canvas we're telling the context to draw onto the canvas. So that's just how we need to do it. Clear rect clears out our canvas so that we can redraw it each time. If we did draw text on screen, it's automatically going to be centered. It's a relic. You can leave that, delete it if it's in your way. Doesn't matter. So now we draw the sky. We tell the context to draw the sky image, source X and Y, destination X and Y, or X, Y, width, and height, sorry. Source X, Y, width, and height, destination X, Y, width, and height. CW is the canvas width, CH is the canvas height. So 0, 0. Now, my sky image is 1800 pixels wide. So if I didn't do this and just drew it on screen, it would actually squish it to make it fit. And that would be problematic because then it would look weird. Weirder than it already does. So that's why I specify which source I am trying to draw. So now if we go back and look, we'll see there's my daytime sky. And if I shift over 900 pixels, that gives me my nighttime sky, because it's just one giant long strip. That's what the sky is. I like the night one. We'll leave it. Currently, I'm drawing 10 clouds on screen. We use a loop to loop through the number of clouds that we have, and we draw those clouds onto the screen. Just can't remember how many clouds I made. So I made 100 clouds that I could put up to 100 clouds on screen. So we'll play with the numbers here and see what happens. So if I just change number of clouds, right now it's at 10. We can see what 10 looks like. If I bring it up to 50, we'll see there's 50. And if I bring it up to 100, I can see there's 100 happening. Simple for loop to loop through all of the clouds. Tell each cloud to update. That updates its position. We don't have to call display on the cloud because the cloud is a single frame object. Single frame objects don't need to update their display or which artwork they're showing. And then finally, draw the cloud image on screen at the source X and Y, destination, source width and height, and then give it its destination X, destination Y, and then at the width and height that we wanted to show up. I shifted it up by 20 so the clouds weren't running through the ground because that looked really silly. Just for kicks, I can make my clouds skinny, or I could even make my clouds tiny. So you can see how we're able to modify those because that's our destination scale or size that we wanted to appear. If I want my clouds to be really, so we can change the cloud artwork. So there's a lot of possibilities that you can just do some simple scale or math operations and it revises your artwork quite dramatically without having to make new artwork. So if you're able to change it this way, that would be a way to go about doing so. And finally, the unicorn. The unicorn draws an image on screen and then it's going to update itself. Then it's going to call its display method. But it doesn't draw a file. It grabs out of the unicorn image files, and then it's going to choose which frame of that to draw onto the screen. And finally, we end with calling request animation frame, and it calls start animating, which is this animation. Where is that? Right here. So start animating, so it just calls that chunk. So this set of code here clears the canvas, draws the sky, draws the clouds, draws the unicorn, repeat 60 times a second. And that is how we can accomplish separate file animation. There are some performance issues that if we had too many objects on screen, we do watch the whole thing starts to crater on us, and we have to take that into account. So if I were to go up to it and say I want 1,000 clouds, we're going to find that we'll get some performance issues that can happen. Dealing with the cloud problem, we just need to shift it over a little bit. So we add in the clouds with, so we add in the clouds width in what we're trying to do, but not just the width. We actually want to guarantee it's going to be enough, and we are going to add that together, put that in parentheses, but then we can subtract, and I'm just going to copy this so I don't have to retype all of that. Paste that in, then we subtract. So this now guarantees we're able to put it some on the left, some on the right side of the canvas when we're all the way done. Because if we end up working this, it's now going to give us enough spacing to work on. Now we have a gazillion clouds, and there's always going to be enough overlap that we're never going to get the ugly gap occurring in our clouds. And it works. The Spritesheet animation is going to be very similar to the separate file animation with a few changes. So instead of loading separate images one at a time, we're now going to be loading images that are part of a sprite sheet. So if we look at the sheet, we can see there's how the images look on that. Now to accomplish this, what we need to do with the Spritesheet animation, this time instead of loading separate images, we're going to load the Spritesheet file itself, which has all of the image assets for the unicorn on it. Now the cloud and the sky are separate files. So we're loading a couple assets. We're not loading a single file. So our asset count in this case is 3 because I have my sky, my cloud, and my unicorn Spritesheet. That's different than the separate file animation where I had to load my sky and cloud and my 12 separate image files. So that makes the Spritesheet animation a little bit more efficient because we're only loading 3 assets. Every time we have to make a server call to load assets, that can slow the load of the page. And now when we're storing these separate assets in memory, that can also affect performance. The fewer individual assets that we store, the better the performance ultimately will be. The rest of the image load handler, same as before. Our sprite, now this time we're using our columns, we're using our frames. We don't have to set up our frames into an array like we did before. That would be a way we could go about it, is we could store that data for each one in it. But it's much easier to instead animate where we work our way across and down the sprite sheet. So we set our source x equal to the current frame, and then we use modulus, so we divide by the number of columns, and then we keep the remainder, and then we multiply that by the width of the sprite. So in this case, when we are dealing with the unicorn, there's 2 columns. So a current frame is going to start out at 0. And then 0 divided by anything is still 0. Multiplied by the width is still 0. So our source x for the first frame will be, of course, 0. The next frame, when current frame is 1, 1 divided by the number of columns is going to be 0. So it's 1 divided by 2. So it's going to be 0. And then we're going to have remainder of 1, multiply that by the width of the sprite, and then we are going to then effectively jump over for our x value. Now the y value, when current frame is 0, of course it's still 0. Now when current frame is 1, 1 divided by the number of columns, and then we round that down. So 1 divided by 2 is 0.5. 0.5 rounded down is still 0. 0 times the height of the sprite is 0. Now when current frame is 1 or 2, so when current frame goes up from 0 to 1 up to 2, so when current frame is 2, 2 divided by the number of columns, which will be 2. 2 divided by 2 is 1. 1 times or multiplied by the height of the sprite will be whatever the height of our unicorn is, 98. So that bumps us down. So current frame is 0, we get this unicorn. Current frame is 1, we get this unicorn. Current frame is 2, so 2 divided by 2, that's 1, the height of the sprite. That puts our y value now onto row 2. And now when we get to 3, 3 divided by the number of columns, which is 2. 3 divided by 2, 2 goes into it 1 time, remainder of 1. So then that multiplied by the width, that brings us all the way over to here, because 0, 1, 2, 3. 3, we're trying to get to that sprite. And then our height. So current frame divided by 3 divided by our columns, which would be 3 divided by 2, which would be 1.5. Rounded down, that's 1 times the height of the sprite. So then that means we're now kind of 1 and 1 on our grid. That puts our registration point here. And then we just continue that math and we work our way all the way down until current frame is equal to the total number of frames. Then we reset current frame back to 0. And that is how we're able to navigate our way across and then down, across and then down, across and down until we hit the end of the sprite sheet. Then we go back to the beginning. So this magic of working with a sprite sheet where all of the frames are the same size. That's one of the requirements on working on a sprite sheet. All the frames have to be the same size. When we are working with a texture atlas, it's actually possible to use frames that are not all the same size for a given sprite. So we can get away with that because we can copy pixels from a smaller area than the full size of the sprite, and the JSON file can tell us how we're supposed to offset that artwork compared to the primary registration of that sprite object. So it can be a more advanced and efficient way of working, but the sprite sheet way is pretty straightforward. This core code of navigating through the grid of sprites when we have a sprite sheet is something that once you have it, you can copy paste it between projects and work with it. Now, one more word about things that I didn't mention before. When we are talking about properties with a key and value relationship, we reference the key, we give it an initial value. Inside of a method or function, when I'm talking about that particular property of this object, we preface it with the keyword this. That's why we say this dx plus equals this vx. And then if this dx is greater than canvas width, well, canvas doesn't belong to the object. Canvas is to the canvas itself. That's why I don't have to preface that in with the word this. Display changed between the single animation project. So display before we just updated the current frame because then we're cycling through the images. In sprite sheet animation, we have to cycle through and modify our source X and Y position to say what pixels we're going to copy for each frame. After that, it's going to be pretty much the same thing. We have our height and our width, frames. This time we do care about columns because we do have 2 columns. The X is the same. Now the clouds, I don't have to do anything different on the clouds because the clouds are just 1 frame. I already defined the frame. I already said it's 1 frame, 1 column. We're done. Because if we go back and look here, 1 frame, 1 column. So we're good. So the code, if I call display in the cloud, it'll be like, whatever. I don't care. It's 1 frame. There's nothing to animate because it doesn't have its own sprite sheet with it. And after that, when I look at what's happening, here's the unicorn. I just draw it at SX and SY. Call update display, and it runs. Done. So the only thing that really changes appreciably is this display method between single frame and sprite sheet animation. That's where we see the change occurring, is how do we display it? Because in the single frame then we have to say which image we want to display. In the sprite sheet, we're always displaying the same image. We are just specifying a different portion or a different section of the image to show on screen at any one time. That's the only real difference between Spritesheet versus separate file animation. If you have multiple images and you have multiple sprite sheets for it, no big deal. You just make different images where all you have to do is create your different objects and specify the correct width, height, number of frames, and number of columns. That's it. And then your sprite sheet will work. Done. It is that straightforward. Working with the Open Weather Map, combining that with the Texture Atlas allows us to have the best part of animating. So we can see there, sprite, frame, sprite, none of that's changed. And now we load the atlas. We're loading 1 image. We have our HXR for the sprites. That loads the information. Once again, we do have to make sure when we're testing locally that we are using something like the live server. Otherwise, it will fail because we will run into our security problem. Got the objects that I'm loading. I'm loading some clouds in this example. Now, again, grabbing the sky, sun, moon, unicorn, added back in the missing lines for the height and width for the unicorn that Firefox wants, and then loading all the clouds in. So none of that is any different than the previous. The weather data, it's the same. I did pull the lat and lon out into their own variables just to make it easier. If you want to choose a new location, you just put in new lat and lon data right here, and then that will update when we grab Open Weather Map and request the JSON from that. We can go grab the weather data from that information. Now I separated out showing the text above the web banner, which showed the location, time, and temperature, and just put that into a function just to make it a little bit cleaner and easier to read. And then we call start animating after that. Start animating is then going to call the start animating function, which is what we've been working with in the previous texture atlas. But we also have the date and time information, which we did play with this previously, where we grabbed what is the current time. Now, I set it up with a spoofed timestamp so that I could then pretend it was nighttime during the daytime. So that's what this value is. Now that I'm running this at night, I can leave it with the live weather and see what happens. Sunrise, sunset. There was a little issue determining whether it was daytime or nighttime previously, and percentages of showing that on screen I realized partway through the presentation last time. So I calculated how many seconds of time are available during the day. So we take our sunset, subtract the sunrise timestamps. That tells us how many seconds we're looking at. Nighttime, we take the total number of seconds in a day and subtract how many seconds were present during that day to give us how many seconds we're working with for our nighttime percentage. Because then we want to know, based on the current timestamp, where are we sitting within that window. So we calculate that information, and then we let daytime be equal to, if sunrise is less than our date timestamp and our date timestamp is less than sunset, then we know that it's daytime. Otherwise, daytime will be set to false. If you want to spoof that value of daytime to day or night, you can either do like I did and change the time up here, or you can just go daytime equals and then type in false after it, or true when you're doing your testing. Position percentage, again, that was last session. We looked at that where we're calculating how much of the day has passed. So we take your date and timestamp, subtract sunrise from it, so we figure out what percent of the day has occurred, divided by the number of seconds. Or we take it, where's the current time compared to the sunset, divide that by the nighttime seconds, and that again gives us the percentage of where should the sun or moon be placed in the sky while we're animating it. If it's daytime, our sky x is 0, otherwise we shift it over by 900 to use my nighttime sky. You could then load a different value. I mean, because I did my combo sky, that's the way that I'm working with it here. Now, the sun and moon, we're going to set its Y position so it rises up and then kind of comes down based on how much. So when it hits the midpoint of day or night, it's going to effectively be at the midpoint on screen. So we figure out that position percentage. And this is a really long statement that doesn't fit with scaled up text. But if position percentage is less than 0.5, then we're going to set the Y position for the sun moon equal to the height of the canvas minus position percentage times the canvas height times 2. Otherwise, that means we want the sun to start going down, so then we do a subtraction of 0.5 from it, multiplied by the height of the canvas. So we're taking this percentage and applying it to the overall height of the canvas. So if our canvas in this case is 200 pixels, when the sun is at the halfway point, it's going to be up at the top of the screen. When we're at the beginning or end of our time window, day or night, the sun is going to be down near the bottom of it. The X position for the sun moon is just going to be a percentage of the width of the canvas, period. That means it moves all the way across the screen as we run it. So if I want to see what's happening within this, we can see right now we haven't hit full sunset yet, so there it is. If I modify the date time here, that now creates sunset, and now we can see we got to the night clouds, night sky, and it went from sun to a moon. Because I believe the nighttime right now is like 8:40-ish, and it's only 8:33, therefore the sun hasn't set for the day. The weather is clear, so right now, so that takes care of the sun moon. Then we draw the sky. If it's daytime, we draw the sun. Oh, this one doesn't change the position of the sun. I forgot to actually. So the sun doesn't really show, or moon at the moment, simply because we are near the end of the day, so it's pretty much off screen at the moment. Now you could modify the range in which you show it so that it never, you shrink that window so it always is going to be a little bit on screen if you wanted, and that's fine too. So you could do that. Now here, I'm drawing a fixed number of clouds. I'm just doing 10. I'm not varying my clouds based on the weather data yet. That's what we'll do shortly. Draw the clouds. It also has, so if it's not daytime, we go and find the night cloud artwork, and then we set the source X and Y for my cloud to the frame X and Y for the night cloud. Knowing my two clouds are the same size, I only need to update the X and Y property, and then that works out fine. And then I'm able to just have one draw statement. You could make it separate, like sun and moon, if you wanted, and make it more complex if you had more variability in your artwork. Because my artwork just changes color, but it's essentially the same, I can get away with doing it that way. There's lots of different ways you can solve the problem of how do I show a range of artwork for day and night. This example uses a couple of different ways of doing it. Sliding the artwork over, just swapping out the artwork that we're showing, or having completely different artwork like the sun and moon. Whatever works for you is totally fine. You get to combine different things together as part of it. And then finally, draw the unicorn, update and display, request animation frame. So that gives us the base part of it. Now the real fun part is when we now take the information from that weather, and then not only do we figure out the sun, the sky, the moon, and all of that, we want to determine what kind of weather to draw. So then we need to process the weather condition data. And what we do is we're going to get a weather code. The weather code that we can get is, if we look in the JSON, weather is our JSON object. Then we look in the weather column. We find item 0. We're going to grab the icon, and then we're going to shorten it a little bit. So in my weather, now if I go look under weather, I will see it's an array. Currently, it only gave me one element because weather, it actually can return multiple items in that. So we have to say, I want to grab the first item in the array at position 0. So that's where I go weather 0. So we can see weather 0. And then within that, what I am looking for is I am looking for this icon. This icon is what we're going to use from Open Weather Map. So we have this icon list of 01D, 01N. We can see day, night. So it can tell us the day-night value. So we could actually find day and night just by that. But that doesn't help us to figure out where to put our sun or moon in the sky, which is why we're doing the other calculations. But this does give us the weather condition, which is what we care about. Whether it's clear, cloudy, rainy, thunderstorm, snow, mist, this is why we need to have these different kinds of values. So this gives us different weather codes. Now, the only part we care about in the code, we don't care about the day or night value. So we're going to use the JavaScript method of substring, which is going to then give us from position 0, and then I want to count over 2 letters. So if I look at the code will be 0, 1, 2 letters. So looking back here, we can see we have this icon, and it's 3 letters long, but I only want the first 2 letters. So I say start counting at position 0 and give me 2 letters. So that's how we're able to get those values. Then once we know that, we now have a switch statement, which is then going to populate our clouds, or choose how much rain to show, or how much snow. Now, if you go back up into the creation stuff, this document also loads rain and snow. And those are array elements, and each one I set to a base of 1,000. So you could have 1,000 raindrops, 1,000 snowflakes, or 1,000 clouds, or all 3 if you really wanted to have a really bad weather experience. What you could do, you could decide that one of the weather conditions is really bad and do it. Now, we haven't figured out how to put lightning in. That's going to be something that you can work on. Lightning is going to be similar to adding any other element. And then mist, whatever you want to do for mist, whether it's lots of clouds or you have new artwork that you're going to show. So I said, I will set a value of mist weather. It's a Boolean, and set it equal to true. By default, mist weather starts out at false. So when mist weather is true, then I want to show something on screen. So maybe I show normal weather, or I have clouds that are kind of transparent so I can kind of see the sun through it, so it's almost like foggy. You could do that. Now, drawing snow, drawing rain, we'll see they look identical except one draws snow, one draws rain. I put a little bit of extra fun in on my snowflakes so that they have a little bit of wiggle to them. I'm going to just change that slightly and change my weather condition. Let's see, snow is 13. So I'm just going to change the weather code, hard code it in at 13. So now if I save this and go back here, I need to now load part 2. So now you can see we got some snow coming down. And I want a little more variability back in the snow, so let's go find that. So now you can see the snow is kind of wiggling its way down a little bit. If that's too wiggly and I want to do something else, well, I can modify that amount. Cut it in half so I get a little bit of wiggle going on with the snow. There's my clouds. You can see the moon is in the sky. So when you're testing your situations, all you have to do is hard code in a weather code and see what happens. So if I want to choose rain 09, save that. Now we can see rain is coming down and a bunch of clouds. All we have to do is modify how much rain, how much snow, how many clouds we want to have happen for each of the weather conditions. And then if there's lightning, you could put that under a thunderstorm. So then you would figure out what you want to put for lightning.